inequalities. So we've been solving systems of equations, so with the equal sign. Today we're going to be doing it for inequalities. So we're going to start with graphing them. Remember, when we graph inequalities, we have to think about two things. Should my line be dotted or solid? And should I be shading above or below? Right? If I have either one of those symbols, is my line going to be dotted or solid? Dotted, because it's not included. If I have the equal to sign, then it's going to be solid. Right? So these ones are dotted, these ones are solid. Right? Okay? Also, if I have either one of these, this would say y is less than whatever the equation is. I'm going to be shading below. If I have either one of these, I'm going to be shading above. Okay, so we've done this before. The only difference in what we're doing today is we're going to draw two lines on the same graph instead of just one line, like we have in the past. Okay, so it says to solve a system of inequalities, graph the inequalities on the same coordinate plane. The solution, or our answer, is going to be the region that's shaded for both. Okay, so when they drew this solid line, they were shading, it says, we're here at the one that started at -1, we're shading below, right? Y is less than. So they shaded underneath this line, right? For the other one, y is greater than x over 3 plus 2. So this one right here, they shaded above. The area that those two had in common was this part right here. That's where it was shaded for both. So that would have been our answer, or our solution. Okay, the part that's double shaded. Okay. So we are going to try a couple ourselves. So on this first one, it says to graph x is greater than or equal to -1. Okay, so it's just the x. There's no y and then some x. So I'm looking for the x value of -1. That would be right here, right? Okay, x is going to be -1 if I go up and down. But if I go to the left, it's no longer -1. If I go to the right, it's -1. So remember, this is our vertical line. Okay. And at this point, should I have a dotted or solid line for x? Solid. So there's my line. Okay. And I want to show that x is greater than -1. So am I going to be shading to the left or to the right? So I'll be shading everything over here. Make sure you don't shade too dark because you do want to be able to tell where they overlap. Okay, for this other one, we want to show that y is less than 1. So I'm going to go to where y is 1, which is on the y-axis, right? So that would have been right here. And if I go up, I'm no longer at 1. If I go down, I'm no longer at 1. So this must be the horizontal line. And with this inequality, is my line going to be dotted or solid? Good. So I have a dotted horizontal line at 1. Okay. And if y is less than, am I shading above or below that line? Below. So okay. And now I'm just looking for the area that was double shaded, that we had to shade for both. That would be this area right here, right? So this part right here is my solution. So make sure that whatever part you're double shading looks darker than the other, so it's easy to see which part is your solution. Okay? All right, let's do another one. So these ones actually look more like a normal equation. That first one, these are all in y equals mx plus b form, and there's no plus b, it must start where? 0. Okay? And in front of my x, I have a negative, so which way is my slope going to slant? Yeah, this direction, right? Okay, and if it's just a negative, that means it's a -1. So I'll be going down 1 over 1 and making it slant that direction, right? So I plot my points. Okay, for my line, for this one, should it be dotted or solid? Good. Okay. And am I shading above or below that line? Below. Okay. Now I have to graph the second line. Where does it say that one starts? 1 on the y-axis, right? So don't go left or right 1, go up 1. So it starts right here. And I need to be going what for my slope? Good. And this one's positive, right? So it's going to slant the other direction. I'm good. All right. So my second one, here it is. Is it going to be a dotted or solid line? Dotted. Okay, and should I be shading above or below? Below. So I'm going to shade everything underneath this line. Okay. So now I'm just looking for where it's double shaded, which would be this little area right here, right? So make sure that that part is darker. Okay. Okay. Number 3. First one, where does it start? Good. Okay. And my slope is -4, so what am I going to be doing for my points? Right. 1, 2, 3, 4 over 1. Since it's negative, we know it slants in this direction. Okay. And do I have a dotted or solid line there? Good. All right. And then that second equation, where does that one start? Good. All right, and then this slope is positive 3, so it slants the other direction going up 3 over 1. Okay, dotted or solid line? Okay. All right, so for my first one, this one right here, y is less than -4x. I needed to shade below, right? So I shade underneath the dotted line. And then for my other one, it is y is greater than 3x minus 2. So for that one, I need to shade above. So my area that's double shaded would be this part over here. Okay. All right, I want you guys to try numbers 4 and 5, and then we'll check them together. So on number 4, my first line, where did it start? 4. So 1, 2, 3, 4. Also, I've noticed walking around, a lot of you guys are trying to start over here at 4. This is a y-intercept, so we always start on the y-axis, right? Okay, and my slope is -1, so I go down 1 over 1. Okay, and And do I connect them with a dotted or solid line? And where do I want to shade? Good. Okay. And then my second one starts at -2. This one has a positive slope, so it slants the opposite direction, and I'm going up 2/1. Okay, and do I connect this one with a dotted or solid line? And do I want to shade above or below? Below. So everything below this line. Alright, so the area I double shaded is right here. So just make sure you really darken that area in. Okay, number 5, where does that equation start? Okay, and the 3 tells us it's positive, and we're going up 3/1. Okay, and do I want to make it dotted or solid? Good. And I'm shading where? Where do I want to shade this one? Up. Okay, second one starts at +1. It also has positive slope, so it'll slant the same way, but we're going up 1/1, right? And this one had the =2 sign as well, so it's solid. And where am I shading for this one? Below. So the region we double shaded is this area right in between the lines. So just make sure you make that section dark. Any questions on the graph part? Good there? Okay, flip it over on the back. Okay, so they give us some word problems here. And we are going to set up a system of inequalities. So we've been practicing setting up the equations. We're going to do the inequalities, but we're not going to solve them. We're just going to set up the equations. Right? So it says you can work at most 20 hours next week. You need to earn at least $92 to cover your weekly expenses. Your dog walking job pays $7.50 per hour, and your job as a car wash attendant pays $6 per hour. Write a system of linear inequalities to model the situation. Okay, so they gave us two totals, right? They told us you can only work 20 hours, and they told us you had to make at least $92. So we're going to need one equation for the hours, one equation for the money, or inequality. We're going to put inequalities in here. All right, so for the money, how much do you make at your dog walking job? $7.50 an hour. So $7.50 per hour for the dog walking job. So maybe D for dog walking. And then we have that word and, which means we need to add. And how much does she make at the car washing job? $6. So 6, maybe C for car washing. Okay. And then it says we had to earn at least $92. So if I need at least $92, does that mean 92 or more or 92 or less? 92 or more. So what inequality would show that this is more or equal to 92? So that's what I need. Did you have a question? Alright, so that's the one for our money, right? Alright, we also have to have one for the hours. So do we have any idea how many hours she plans on working the dog walking job? So we'll just have to put D for dog walking hours. She also has this other job, so we need to add to it the hours she will make. She will be working at the car wash. Again, we have no idea how many hours, so maybe C for the car wash job. But the most she can work is 20 hours. So does that mean she could work any more than 20? So I need to show that this is less than or equal to 20 hours, right? So I would need to put this inequality to show that, right? Okay, so here's our system of inequalities, and you don't have to solve. Just set up the two inequalities. All right. Number 2 says, Jonah is going to the store to buy candles. Small candles cost $3.50 and large candles cost $5. He needs to buy at least 20 candles, and he cannot spend more than $80. Write a system of inequalities to represent this situation. Okay, so again, we're going to need one for the money, but then also one to represent the number of candles, right? Okay, so how much does a small candle cost? $3.50, so I'll have $3.50, and we don't know how many that he's getting, so $3.50s for number of small candles. And he can also buy large, again we have that and, so we know we need a plus. The large ones were $5, so 5L. Okay, and this is the money one, so it says he cannot spend more than $80. So that would mean it has to be less than or equal to, right? So there's my first equation. That one's for the money. All right, then we're talking about the number of candles. So there's only 2 types he can buy, right? He can buy small and he can buy large. So I would need to, again, add small and large candles, but he has to buy at least 20. So how would I write that? Very good. So 20 or more, right? Okay. And then last one says, John is packing books into boxes. Each box can hold either 15 small books or 8 large books. He needs to pack at least 35 boxes and at least 350 books. Write a system of linear inequalities to represent this situation. Okay, so these books either are going to be a book made up of small books or a box made up of large books, right? One or the other. But all together, that's going to tell us how many books we end up packing. So how many small books fit in a box? 15. So I would have 15 small book boxes. So we don't know how many of those we're going to pack. And then we also could have the large book boxes, which will hold 8. But altogether, we have to pack at least 350 books. So what inequality would I want for that? Good. Okay, so here's my equation for the books. I also need one for boxes, right? Okay, so there's 2 types of boxes I can pack, right? I can pack the small type or the large type. So small plus large. And he has to pack at least 35 boxes. What would I need there? Right. Also greater than or equal to.